Okay, so this is part 2 of lecture 5, and this is going to cover chemical formulas. So the periodic table is our alphabet. The elements are the alphabet in this language you're learning. Now we're going to start making words with this alphabet you've learned, and those are our chemical formulas. And then also I'm going to cover the naming rules, and that's a bit tricky. There is a video I'll show that helps with it. So that's what we're covering here. Okay. Da, da, da. All right, that's where I left off. So chemical formulas give you a lot of information. For ionic, if you're told the name or what it's composed of, you can write the formula, because the formula exists of two things. One is the element symbol, and the other one is a subscript of how many of each of these atoms or elements are in the molecule. What is the ratio? Remember, molecules exist with whole number ratios of the constituents, and that's what this is. Covalent, so aluminum and oxygen ions will only come together one way, because it has to do with their charge. These are ions. An ionic formula unit is composed of ions. So they already have an existing charge when they come together, and that determines your ratio. Covalent, on the other hand, because you do not have ionic charges, they actually can combine in multiple ways. Carbon and oxygen can combine in plenty of ways. So you have to then simply look at what you have and accept it. That's what that molecule has, this particular oxygen, and then you'll learn to name it by the rules. So this particular one has 1 carbon and 2 oxygens, so this is carbon dioxide. But if it was 1 carbon and 1 oxygen, it would be carbon monoxide, which is a completely different molecule. So, but they are critical. These are the words that we use in our language of chemistry that make up our sentences, that make up our paragraphs, that make up our whole language. So the symbols, of course, we get from the periodic table, so you want to know that. And then the subscript tells you how many of each of these atoms or elements is in that molecule or compound / formula unit. So aluminum oxide has 2 aluminum, in this case it's an ion, and 3 oxygen ions for every single formula unit, because remember, this doesn't travel by itself. This will travel in a crystal with lots of other aluminums and oxygens proportionately around. We write it as the simplest ratio. If you wonder, well, how do we know there are only 2 aluminums and 3 oxygens? Because it's in this crystal. Well, you do have a ratio based on the geometry of the crystal, but most importantly, we write it as the simplest ratio. You wouldn't write 4 aluminums and 6 oxygens, because that can be divided by 2. So it's always the simplest ratio. Not quite the same with the covalent, because that's a different animal. So let's start with the ionic. Remember, a single one is called a formula unit. It's the ratio of each element. Sodium chloride, there's 1 sodium, 1 chloride. Notice that there's no little 1 under here. So we don't put a subscript if it's only 1. If you see just the single element, you assume 1, because there is 1. There's 1 sodium and 1 chloride. You only put the subscript when there's more than 1. And the point of when we write this, how do we know what subscripts to use? Your net charge has to be 0 for a formula unit. You have a positive coming together with a negative. The net charge has to be 0. So if I go back to the previous, aluminum oxide. Okay, look back over to the whiteboard a minute. So there's the compound that I took off the slide. This is an ionic. This is a aluminum is a metal. Oxygen is a nonmetal. So this actually is a formula unit consisting of two of these ions and three of those ions. That's what makes up this. The way you know the ratio is because of these charges. You have to have a net negative. So if I have 2 times a 3 positive charge, I have a 6 positive charge, don't I? And if I have 3 of a 2 minus charge, I have a 6 minus charge. Or you can write this the other way. When I add those together, I get a net 0. That's what every single formula unit will have. You have to combine them in such a way that it is 0. So on the other slide, I had a sodium chloride. Do that in a different color. Since I only have so much room on this, I had a sodium chloride, and this is actually, you'll see this a lot. It's very common. Well, this is composed, sodium ion exists like that. Chloride ion exists like that. This is their form. Sodium loses 1 electron to get to the noble gas configuration. If you look on the periodic table, it's right there. It loses 1. It zips up to the previous level. Chloride has 7, so it adds 1. Now it has a noble gas configuration, and it has a -1 charge. So each of these has fully paired electrons. So when they come together, you only have a 1 plus here and a 1 minus there, and that is going to give you a net 0. So that's why sodium chloride has a net 0. They have to perfectly balance each other out. Your positives and your negatives have to balance each other out. So a quick way to do this is the crossover. Especially, you're like, oh, that looks a little confusing. How can I figure that out? Well, if you are going to say, I'm putting these atoms together, ions, excuse me, what are their numbers going to be? This charge goes down there, and this charge goes down there. There's your numbers. So I'm going to rewrite my symbol. There's aluminum. This charge goes down here. There's my oxygen. And this charge goes down here. And there you are. So that's your shortcut, the crisscross. Take the charges of the ions and crisscross it. Put it down on the other ion. That will balance you out. If you do that and you end up for some reason, and I'm just going to make these up, we're gonna call them X and Y. If you do that and you end up with numbers that can still be divided down, do so, because you've got to have the lowest ratio. 4 and 2 can be divided by 2, can't they? So you would actually rewrite this like this. You have to write it as the simplest form. So if you do the X, like I said, I made this up, but if I had, we'll go back up here, X had a 2 negative charge and a 2 plus charge, and Y had a 4 negative, right? And I crisscrossed, and I got this. Continue reducing until you have the lowest ratio. So this wouldn't be, you're not done. X2Y would be your formula unit because it has to have the lowest ratio. These have to be, can no longer be minimized down. All right. So this will save you tons of time. Just don't forget to simplify it as much as possible. All right, back to PowerPoint. Okay, so that is how for ions, for an ionic compound, ionic formula unit, you write the formula. But remember, covalent, you can have all kinds of combinations because you're sharing. So you'll probably be given a name, and then you will take the name and write the formula, which is what we're moving into. So each of these has naming rules. So that when you hear it, you know this is what it means, or this is what it means. You can write it down. Okay. And here are the rules for writing ionic formulas. Now, I just went through this, most of it. The cation is written first. If you go back and look at my whiteboard examples, you always write the cation first. This is just our procedure. So your metal is first. And remember, this is ionic. You write your subscripts, which is the ratio of each element or each ion, such that the total result is neutral. You will not have a charge on your finished ion, because your finished ionic, your formula unit, your ionic compound, your finished ionic compound is neutral. The charges have canceled each other out. They're balancing each other out, actually. So your ionic compound does not have a charge on it because it's neutral, and you're going to write it in such a way that it's neutral, which is the crisscross method. But remember that you have to reduce those ratios down if they can still be divided by something. So your final formula unit, your final, chemical formula is the simplest ratio. Can't be broken down anymore. And remember, a 1, we don't write the 1 down. So if there's just the unit element symbol, you know that there's one of those. And when we write that, the finished chemical formula, your word in chemistry, this is your word, there are no more, their charges are not showing anymore. That's the whole point of this, is you've balanced it. So you now have, see, there's no charges here anywhere because it's balanced. It has a net zero. Okay. So sometimes you're going to see, actually often, something like this. This is called a polyatomic ion. Notice the chemical formula here. There's more than one atom or one element, but there's this charge. The entire molecule has a charge on it. And so you treat this as a single unit. Nitrate, you treat as a single unit. Sulfate, you treat as a single unit. It's always going to be treated like a single unit. So this is still an X and a Y. My made up example of X and Y, this Y just happens to have a few more elements. This particular, if you look up in the periodic table, sulfur and oxygen are both nonmetals. Within it, these are covalently bonded to each other. But for whatever reason, and this is very, very common with the ones we're going to move into, it travels with a charge on it. And so therefore it can go into an ionic compound. So this, they have negative charges. It can go into an ionic compound with a positively charged ion and make a formula. And you follow the same rules. So let's go back to the whiteboard for a minute and look at sodium sulfate here. I'll erase it when I get to it. So here was my example before. You're going to use the same process when you're using a polyatomic ion. So I got this from the crisscross method. The second example given on that slide was sodium, right? You have sodium, but then you have this polyatomic ion here. That's a 4. The entire thing has the 2 minus charge on it. It travels as a unit. So treat it like Y. This is the same thing as a Y2 minus. Y was my little made up here. So if I crisscross, the 2 will go down here and the 1 will go over there, the numbers, not the elements. So we have sodium. I pull the 2 over here because of my crisscross. I don't pull a 1 down there. We don't add 1. So this is how you would write that. It is still electrically neutral. The charges are balancing out. If you have a situation where you have more than one of these units, you would put that unit in parentheses because the subscript goes for the whole unit. So if we have magnesium, which has a 2+ charge, and you're going to combine it with nitrate, which has a minus charge, do you crisscross? Well, I can't do it without crossing in front of nitrate. So sorry, nitrate, you know what I'm doing, right? So magnesium gets a 1, and we don't write the 1. But nitrate is going to have 2 of them. Where do you put the 2? You enclose your unit and put the 2 outside. You only do that if you have to actually put a subscript down there. Otherwise, you're like, well, where do I put the 2? So it's this entire unit, this entire polyatomic anion that you have 2 of. So, you know, you have a magnesium and you have a nitrate hovering over here, and you have a nitrate hovering over here, you know, or something. But you have 2 nitrates for every 1 magnesium. And so you put your parentheses around your polyatomic anion and put your 2 on the outside of it. So the rule is the same. You use your XY crisscross. It's just that you have to put parentheses to show that this entire structure you have 2 of. You should have homework in Alex that helps you practice this. Okay. So that was, here's an example where you had to have 2, here's the nitrate. I use magnesium, the slide uses calcium. Calcium has a 2+ charge. Nitrate has a -1, so you have 2 nitrate ions for every 1 calcium. So you have to put the nitrate in a parenthesis. But if you only have 1, you don't use a parenthesis. Okay, so use this as a reference. And notice that nothing is showing a charge in the final chemical formula because it's net neutral. You've written it so that all the charges balance out. We do not write a charge anywhere. These are no longer ions. It's an ionic bond, it's an ionic compound. It's a formula unit. Okay, these are just some more examples and a repeat of what I was explaining. So review these to get comfortable with it. All right. Some metals can have more than 1 ionic state. And You will be memorizing them. There is slide. Hang on. No, that's not it. Here. So this is slide 32. You do need to know these. Not mercury so much, but you need to know the others. And aluminum is up here with the 3+. So, and you have to know that SN is tin, PB is lead. This is copper. So copper has either a 2+ or a 1+. So if you are told that copper is in complex with oxygen, how do you know how many coppers to put in there? You have to be told that it's either copper 1 or copper 2. Copper with the 1+ charge or copper with the 2+ charge. So you have to be told that, and we put it in the name. Otherwise, you won't know. If you're given the formula, you'll know, because when we look at this chemical formula, I have 2 coppers and I have 1 oxygen. Oxygen is always 2- as an ion. And so if I have 2 of something, I need to balance out a 2- charge, then each one of those must be 1+. Right? So 2 times a 1+ charge will give you 2+. 2- gives you a net 0. So, okay, so here are some examples. I will go to the whiteboard to work each of these, since I didn't do lecture today. Try to work them out with me so that you can figure out the answers. All right, I'm going to erase my little XY. So the first example is we have these 2 ions, calcium, ion. Remember, if it's a cation, we just say the name and the word ion, but if it's an anion, we end it with IDE, right? If you use the crisscross rule, it's really easy to write down this formula unit. You write your calcium first. You write your cation first. It's going to have nitrogen's charge. You write your anion. It's going to have calcium's charge. You check, is this the simplest ratio? Yes, 3 and 2, you can't break that down any further. And so if you were to go back and look at that slide, the answer is B. Is this? So the second example, since it's too hard for me to bounce back and forth, is barium, which has a 2+ charge, and nitrate ion. This is a polyatomic. So and the next section is going to be learning how to name these. Okay. So with my crisscross, this 2 is going to go down there, and that 1 is going to go down there. So barium, I only have 1. But my nitrate, I'm going to have 2 of, right? So you have to put it in parentheses because you have 2 of this entire unit. So that would be D on the slide. And again, this can't be broken down any simpler. So the third example is tin. Tin is one of those that has more than 1 charge, but we're told that this has the 4+ charge. An oxide ion. Anions have the IDE ending, so that's oxide ion. Again, we're going to do the crisscross. So that means my tin is going to get the oxygen charge, and my oxygen is going to get the tin charge as a subscript. However, this can be broken down further, can't it? 2 and 4 can be divided by 2. That's generally going to be your rule. So we're not done. You have to reduce this to the simplest form. And so that is your answer. And that is E on the slide. Answer E. Oops. Let's see. Okay. So some more examples. I think if I full screen this, no, all right. So with calcium and nitride, try to do these examples using the periodic table. Figure out the ions yourself. So if you're only given these words, look it up, find calcium, figure out what ion it would make. The same thing with nitrogen. You see nitride, you know that's an anion version of nitrogen. The answers are given for you here, so work through each one of these. These are all going to be a metal and a non-metal. And practice being able to work through this type of a problem. Okay, I will stop this one here because then we're going to go to naming, and that takes a bit of time. So this is part 2 of lecture 5 ending, and I'm about to start part 3, which is going to be naming.